Evaluate integral x square positive x positive 1 over 2x positive 1 times x square positive 1 dx. So we have to integrate this rational function. To integrate the rational function, so what I'm going to do is I'm going to write this rational function into partial fractions. Okay, so to write this rational function into partial fraction, first I have to look at the denominator. So the denominator is a product of two binomials. So here, the first binomial is having exponent 1. So we just have to write only one fraction for this binomial. And look at the exponent of the variable x inside the parenthesis. That is also 1. So the numerator of this fraction will just be a constant, say a. And in denominator, you have to write this binomial as it is. Okay, when I go to the second binomial, the exponent is 1. So for this one also, I have to write only one fraction. When I look at the expression inside the parenthesis, it's x squared positive 1. If I find the derivative of this one, it will be 2x. So the derivative of x squared positive 1 contains x. So here, in this fraction, the numerator also must contain x. So we can write the numerator as bx positive c. And the denominator is going to be x squared positive 1. Okay, so now what we need to do is I have to find the values of these three unknown constants a, b, and c. For that, I have to simplify the expression I have on the right side. Okay, to simplify the expression I have on the right side, I have to get the common denominator for these two fractions. So there is nothing but the least common multiple of the two denominators, 2x positive 1 and x squared positive 1. So the least common multiple of these two denominators is the one what we have in denominator on the left side. So the denominator of each fraction on the right side must be 2x positive 1 times x squared positive 1. So okay, let's do it in the next step. Okay, to get this denominator for the first fraction, I need to multiply both numerator and denominator by x squared positive 1. Positive bx positive c over x squared positive 1. Okay, to get this one as denominator for the second fraction, I need to multiply the second fraction, numerator and denominator of the second fraction by 2x positive 1. Okay, now I got the common denominator, that is 2x positive 1 times x squared positive 1. Okay, let me continue on the next step. So x squared positive x positive 1 over 2x positive 1 times x squared positive 1. So here I have the same denominator for both the fractions. So I can take the denominator in common, that is 2x positive 1 times x squared positive 1. So the numerator of the first fraction is a times x squared positive 1. Positive, the numerator of the second fraction is bx positive c times 2x positive 1. Okay, here we have the same denominator on both sides, that is 2x positive 1 times x squared positive 1. If I multiply both sides by 2x positive 1 times x squared positive 1, this one and this one will cancel out. So the resulting equation will be x squared positive x positive 1 equals to a times x squared positive 1 positive bx positive c times 2x positive 1. Okay, now in this equation, I have to solve for, I have to find the values of the unknown constants a, b, and c. Okay, let's continue on the next page. Here, to get the values of the constants a, b, and c, I can equate the coefficients of x squared, x, and constant term. Here, the two expressions are equal. Whenever two expressions are equal, the coefficients of like terms can be equated. So here we have only one term with x squared. So the coefficient of x squared on the left side is 1. So the same way I have to get the coefficients of x squared on the right side also. Okay, first let's compare the coefficients of x squared. So the coefficient of, there is only one term contains x squared on the left side and it has coefficient 1. Okay, on the right side, if I distribute a to x squared, it will be ax squared. So the coefficient of x squared is just a, the first term on the right side. Okay, now I'm moving to the second term. If I distribute this bx to 2x, it will be 2bx squared. The coefficient of x squared is just 2b. So a positive 2b. Okay, so when I compare the coefficients of x square, I am getting an equation 1 is equal to a positive 2b. I just consider this is equation number 1. Okay, now I'm going to compare the coefficients of x. Here on the left side, there is only one term which contains x. Its coefficient is just 1. On the right side, if I distribute a to x square and a to 1, I don't get any term which contains x. So now I have to check with the second term. If I distribute this bx to 2x, I'll be getting 2bx square. But I need the term which contains x alone, not x square. Okay, if I distribute this bx to 1, it will be just bx. Bx times 1 is bx. Here I'm getting the coefficient of x, b. Okay, now if I distribute this c to 2x, it will be 2cx. So the coefficient of x here is 2c. Okay, I'm getting an equation when I compare the coefficients of x, that is 1 is going to be positive 2c. I consider this is equation number 2. Okay, now I'm going to compare the constant terms. On the left side, the constant term here is just 1. On the right side, if I distribute this a to 1, it will be a times 1 is a. It's just a constant. And in the second term, if I distribute this c to 1, it will be c times 1. That is just c. That's also a constant. So I'm getting equation 3. So now I have, when I compare the coefficients of x square, x, and constant terms, I'm getting 3 equations, 1, 2, and 3. Okay, now I have to solve these 3 equations for the 3 constants a, b, and c. Okay, what I'm going to do is I'm going to take the first equation and third equation and eliminate the constant a. If I eliminate the constant a from the from the equations 1 and 3, I'll be getting the fourth equation which contains b and c. Already we have the second equation which contains b and c, so I can solve the second and fourth equation for b and c. Okay, first let me eliminate the constant a from the equations 1 and 3. For that, I'm going to subtract third equation from the first equation. So I'm taking the first equation as it is, that is 1 is equal to a positive 2b. Okay, since I subtract third equation from first equation, there is a negative sign in front of the third equation. So I have to multiply both sides of the third equation by negative sign. So when I multiply this 1 by negative sign, it will be negative 1, and negative times a will be negative a, and negative times positive c will be negative c. So now this positive 1, negative 1 will cancel out. I get 0. Positive a, negative will cancel out, and I get 2b negative c. So this is equation number 4. Okay, now when we look at equation number 2 and equation number 4, we have the same unknowns b and c. So now I have to solve for b, and when I'm solving the equations 2 and 4, I can get the values of b and c. Once I get the value of b or c, I'll be able to get the value of a. Okay, let's solve equation number 2 and 4 on the next page. Here in equation number 2 and equation number 4, I'm going to eliminate the constant c. Okay, here in equation number 2, I have positive 2c. In equation number 4, I have negative c. Instead of negative c, if I have negative 2c, I can eliminate the constant c by adding equation number 2 and 4. But I have only negative c. I need negative 2c. Okay, for that, I need to multiply the fourth equation by 2. So I multiply the fourth equation by 2. When I multiply the fourth equation by 2, I'll be getting so when I multiply this 0 by 2, it's still 0. And if I multiply this 2b by 2, it will be 4b. If I multiply this negative c by 2, it will become negative c. Okay, I'm taking the second equation as it is. That is 1 is equal to b positive 2c. Okay, now I'm adding these two equations to eliminate the constant c. So the negative 2c, positive 2c will cancel out. And here 0, positive 1 will be, when I add 0 and 1, it will be 1. When I add 4b and b, it will be 5b. To solve for b, I divide both sides by 5. So 5 will cancel out. I get 1 over 5 is equal to b. Okay, now I got the value of b, that is 1 over 5. Okay, so I can plug in the value of b into the first equation to get the value of a. So already I know the first equation, that is 1 is equal to a positive 2b. Okay, so to get the value of a, I have to plug in b is equal to 1 over 5. Let me do it. So a positive 2 times 1 over 5. So 1 is equal to a positive. 2 times 1 is 2. So it's going to be 2 over 5. So I'm going to subtract 2 over 5 from both sides. So this positive 2 over 5, negative 2 over 5 will cancel out. I'm getting 1 negative 2 over 5 is equal to a. Okay, to simplify this one, I have to multiply this integer 1 by this denominator. When I multiply 1 by 5, I'll be getting 5. Once I'm done with this multiplication, I can take this 5 as a common denominator. That is 5 negative 2 over 5 is equal to a. So when I simplify this one, I'll be getting 3. So 3 over 5 is equal to a. Okay, now I got the value of a, that is 3 over 5. Okay, here I can plug in the value of a is equal to 3 over 5 into the third equation to solve for c. Okay, let's do this one on the next page. Here we have the third equation, that is 1 is equal to a positive c. Just now we got the value of a, that is 3 over 5. So we can plug in the value 3 over 5 for a. Okay, now we have to solve for c. I'm going to subtract 3 over 5 from both sides. When I do so, this positive 3 over 5, negative 3 over 5 will cancel out. On the left side, I get 1 negative 3 over 5 is equal to c. Okay, to simplify this one, I have to multiply this integer by the denominator 5. Once I'm done with this multiplication, I can take this 5 as a common denominator. 1 times 5 is going to be just 5. So I get 5 negative 3 over 5 equals to c. Okay, so when I simplify this 5 negative 3, it will be 2 over 5. So I get the value of c, that is c is equal to 2 over 5. Okay, now I got the values of all the three constants, a, b, and c. Now what it is, we have to plug in these three constants into our original problem. Okay, let's go back to the original question. Okay, here we can plug in the values for the constants a, b, and c. So I get the value of a is 3 over 5. So we can witness a can be replaced by 3 over 5. So we get 3 over 5 over 2x positive 1. And here I can plug in the value 1 over 5 for b and 2 over 5 for c. So I get 1 over 5x positive, 2 over 5 over x square positive 1. Okay, in the next step, since the numerator is a fraction, it can be written separately. So that is 3 over 5 times 1 over 2x positive 1 positive. Here, from these two terms, I can factor 1 over 5 out. So if I factor 1 over 5 out, I'll be getting 1 over 5 times x positive 2 over x square positive 1. Okay, let's continue the next step on the next page. Okay, this is a continuity from the previous page. So 3 over 5 times 1 over 2x positive 1. Here positive 1 over 5 times. Here x square positive 1 is a common denominator for x and this 2. So I can take this x square positive 1 as denominator separately for x and separately for this 2. In that case, I'll be getting x over x square positive 1 positive 2 over x square positive 1. Okay, so 3 over 5 times 1 over 2x positive 1 positive. So I'm going to distribute this 1 over 5 to this one. It will be 1 over 5 times x over x square positive 1. If I distribute this 1 over 5 to this one, it will be positive 1 over 5 times 2 over x square positive 1. 3 over 5 times 1 over 2x positive 1, positive 1 over 5 times x over x square positive 1, positive. If I multiply this 1 and 2, it will be 2. So we can write this fraction 1 over 5 as 2 over 5 times 1 over x square positive 1. Okay, let's continue on the next page. Okay, here we can integrate both sides with respect to x. So integral of this part is dx, integral dx. Okay, now on the right side, I can distribute the integration to each of these three parts. So I'm getting integral 3 over 5 times 1 over 2x positive 1 dx positive 1 over 5 times integral 1 over 5 times x over x square positive 1 dx positive integral 2 over 5 times 1 over x square positive 1 dx. Okay, here in the first integration, so this part contains variable. Okay, this the variable part is multiplied by a constant. In integration, whenever the variable part is multiplied by a constant, the constant can be moved out of the integration. So if I move this constant 3 over 5 out of the integration, I'll be getting 3 over 5 times integral 1 over 2x positive 1 times dx positive. The same thing here, 1 over 5 is multiplied by the variable part, so this 1 over 5 constant can be moved out of the integral. I'm getting 1 over 5 times integral x over x square positive 1 dx. So the same thing I have for 2 over 5. So I'm getting 2 over 5 times integral 1 over x square positive 1 dx. Okay, now if I look at the first integration carefully, the denominator is 2x positive 1. So the derivative of this denominator 2x positive 1 with respect to x is just 2. Okay, if I have the derivative of this denominator 2 in numerator, I can integrate this function easily. So now I need the derivative of this part 2x positive 1, which is 2 in numerator. So if I want to get the 2 in numerator, I have to multiply this 1 by 2. So I'm going to multiply the fraction, the first integration by 2. I'm going to multiply the numerator and denominator of this one by 2. So the reason is I need 2 in numerator because the derivative of 2x positive 1 is just 2. Okay, now let's come back to the second integration. The derivative of the denominator x square positive 1 with respect to x is just 2x. So the same I need in numerator, but when I look at the numerator is just x, so it has to be 2x. So here this fraction, in this fraction, I'm going to multiply both numerator and denominator by 2. Have nothing to do with the third integration. Okay, now let's continue. So 3 over 5. So this 2 is not required inside the integration, and also it's a constant multiplied by the variable part. So this 2 can be moved out of the integration. So when it comes out, it will become 1 over 2. And 2 times 1 is 2 over 2x positive 1 dx positive. So the same thing, it's a constant multiplied by the variable part. And this 2 is not required inside the integration. So it can be moved out of the integral. So 1 over 5 times 1 over 2. Because when this constant 2 comes out, it will be 1 over 2 because 2 is in denominator. 1 second. Okay, here inside the second integral, we have 2x over x square positive 1 dx positive 2 over 5 times integral 1 over x square positive 1 dx. Okay, let's continue on the next page. Here, if I simplify this one, I'll be getting 3 over 10 because 3 times 1 is 3 and 2 times 5 is 10. Okay, when I look at the stuff inside the integration, I have 2 over 2x positive 1. If I find the derivative of the denominator 2x positive 1 with respect to x, it's just 2 that we have in numerator. Okay, in integration, whenever we have the derivative of the denominator in numerator, so the integration of such function is natural logarithm of what we have in denominator, that is 2x positive 1. Okay, here, the value of this 2x positive 1 always has to be positive. So because logarithm is defined only for positive values, so the value of this 2x positive 1 always has to be positive. So since this value always has to be positive, we can take absolute sign for this 2x positive 1. Okay, here even for some values of x, if this 2x positive 1 becomes negative, because of the absolute sign, it will be considered as positive. So because the logarithm is defined only for positive values. Positive. When I simplify this one, I'll be getting 1 over 10 because 1 times 1 is 1, 5 times 2 is 10. Okay, when I look at the stuff inside the second integration, the denominator is x square positive 1, its derivative with respect to x is just 2x, that we have in numerator. So the integration of this function is natural logarithm of absolute value of what we have in denominator, that is x square positive 1, positive 2 over 5. Okay, so here I have to find integration of this one. So its integration is arc tan x. First you see. Already we know that the derivative of arc tan x is 1 over x square positive 1. So if I integrate 1 over x square positive 1, it will be arc tan x. Okay, now I got the integration of the given function. So that is 3 over 10 times natural logarithm of 2x positive 1. To a natural logarithm of absolute value of 2x positive 1, positive 1 over 10, natural logarithm of absolute value of x square positive 1, positive 2 over 5 times r tan x positive c.